In this video, I want to take our integration skills just a little bit further by introducing something called the backwards chain rule. And so, as a reminder, if we're finding the derivative of a function like, let's say, e to the power of 3x, the derivative would be e to the power of 3x times the derivative of that function right there, or the slope of that exponent, which would be 3. Similarly, let's say our original function was sine of negative 2x plus 5. The derivative would be, first it'd be the derivative of the outside expression, which is cosine, with the inside staying the same. Finally, times the derivative of the inside expression. So it's the same process for our e's or our trig functions or any composition of multiple functions, where you're going to take the normal derivative, so treat this like e to the monkey. The derivative of e to the monkey is just e to the monkey. It is just what it is. But then you're going to multiply by the derivative of monkey. Similarly here, if we just cross all this out, that negative 2x plus 5, and call it monkey, sine of monkey, then our derivative would be the derivative of the outside, cosine monkey, monkey being unchanged, but in the last step we're going to multiply by monkey's derivative. So we're going to need to have a chain rule that goes backwards too if we want to integrate more complex functions. So let's start with a review. Pause the video here and see if you remember your formulas well enough to integrate this top function. Alright, assuming that you've paused the video, check if you got negative cosine x minus 2 sine x minus 5 e to the x. Don't forget the plus c. And that would be the correct answer. What I'd like you to do now is look at the second example. See why these two are very different. The top one was very simple, sine of just x, cosine of just x, e to the power of just x. But in our second example, I'm complicating the inside function. So not only do we have sine, which is already a function, but now I'm taking sine of 3x, which represents really a line. This is a linear, meaning it's an mx plus b form expression. So it's a function, which is 3x, inside of another function, which is sine. That tells me I'm going to need to use the backwards chain rule. Also, instead of just cosine of x, now I have cosine of 4x, another line with a slope of 4. And even in this e example, it's not e to the regular x anymore. It's more complex. It's got its own line with a slope of negative 1. So these are all linear expressions. So it's important to be able to identify the slope. And this backwards chain rule that I'm about to teach you, which is actually a shortcut, only works if the expression that is inside those parentheses is linear. So write down only works for linear expressions. So for instance, sine of 3x, cosine of negative 2x, e to the negative x, all of these it works. Tangent of 3x minus 1 works as well because that's a line. It's an mx plus b form. These other ones all just had a b of 0, these previous ones up here. Okay, so it has to be linear. It cannot look like this. Our rule won't work here because that's not a linear expression, it's a quadratic. So you need to make sure that x has the power of 1. So won't work there. X has to have a power of 1 to work. So here's how it works. So first we'll take the antiderivative of the outside as normal. So the integral of sine is negative cosine. We'll copy the inside expression, and then we will divide by the slope of the inside line. And the slope was 3, so we divided by 3. Let me guide you again. So we're going to take the derivative of the outside expression. So as always, we'll copy the negative 2. The integral of cosine is just sine. We'll leave everything else the same, and then we will divide by the slope of the linear expression. Let's do it one more time. So I'm copying the minus 5. The integral of e to some number is e to that same thing, and I'm going to divide by the slope, and the slope here is actually -1. It's not so obvious necessarily the first time, but a negative x has a slope of -1. Don't forget the plus c at the end. So now let's rewrite this. I can leave it as is. Of course, I do need to simplify that 2 and that 4 there. And then this -5 divided by -1. So you could leave your answer like that. You could also write it like this: -1/3 cosine 3x minus 1/2, because there's just a 1 here now. So I'm pulling the number in the front, and then sine of 4x, and then plus 5 e to the negative x plus c. So that's how you use the backwards chain rule. Let's see if we can do another problem for practice. So what if I gave you 3 secant squared of 5x minus 4 sine of 2x plus 2e to the 3x. So pause the video here and give this one a shot. Ready? Let's try it. First, we'll pull out the 3. The integral of secant squared is tangent. And, ooh, we have a linear expression, so keep it the same, but divide by its slope. Let's do the next one. First, copy the constant multiplier. The integral of sine is negative cosine. So I'll just flip this to make it a positive and just write cosine. Ooh, we have a linear expression, not just x, so I'll copy it down and divide by its slope. And then for the last piece, we're going to copy the 2. This stays e to the 3x, but we're going to divide by the slope of that linear expression, which is 3 plus c, and we're done. We would simplify the 4 over 2, but otherwise we're good to go. Okay, let's try a harder problem here. So this is where people start to get stuck, and I really want to let you know that if this next problem you find it really challenging, that's okay. This really is the difference between like a 4 and a 5 on the AP exam when it comes to stuff like what we're about to do right now. So it really is okay if it's confusing. So for this problem, the first thing that we'll do is notice that at first it's quite complicated, but I'm going to separate that -4 away from this 1 over square root expression. The reason for that is because I actually have a rule for 1 over the square root of x. Its integral is just 2 root x plus c. So I want to be able to physically see that. So why don't we take this extra step here, pull out that -4 and leave the inside as root 2x plus 3. And while we're at it, let's just separate these two pieces. From here, I can pull out the 6, but I can't pull out the 5 or the 3 because there's a minus sign connecting these two. They're all a single term, or a single expression. So we can pull out the 6, but the rest of it will stay inside 5 minus 3x. Okay, now we have something much simpler to work with. So I want to start here. If you could just for a second ignore that it says 2x plus 3 and instead imagine that it says monkey. Then we can use something really similar to this rule, and it would be 2 root monkey plus c. But since monkey is a line, we will divide by the slope of that monkey. So if you could just for a second, again, ignore that it says 2x plus 3, just plug in the letter m or even the letter x. That leaves us with the -4, and the integral of 1 over root something is 2 root of that something. So I'm going to leave it blank for now. But I want to divide by the slope because this is a linear expression. So we'll divide by the slope, which is 2. Now that inside is going to stay unchanged, as we do with the chain rule. Let's try the next one. So we have plus 6. This time, this should remind you of this rule, whose integral is natural log absolute value of x. However, instead of an x down there, it's a line. So I know chain rule is involved. So I'll go ahead and apply this rule. Instead of 1 over x, it's 1 over monkey. So instead of natural log of x, I'll get the natural log of monkey being that inside expression. But I need to make sure I divide by that slope. Now the slope here is not 5, but it's the negative 3. It's the value in front of the x. Plus c. Simplifying for our final answer, we get negative 4 root 2x plus 3 minus 2, because the 6 and the negative 3 there, natural log 5 minus 3x, close the absolute value, plus c, and that would be our answer. So I would say this is among the more tricky problems that you'll encounter on the AP exam. It doesn't come up too often, but it is good to recognize that you can do something about it. Let me see if I can give you one more problem similar to that at that difficulty level. And again, if you don't feel up for it, that is totally okay. Let's try one more. Here you go. Pause the video here and give it a shot. Okay, so if you were overwhelmed at first, one thing that you could do is pull out the constant multipliers and actually write them separately. Since that root 3x minus 1 is in the bottom, I'll make sure I remember it's in the bottom by writing a times 1 on top. So we have 9 over 5, I'm just pulling it out in front, a 1 over root 3x minus 1, and while we're at it, I'm going to separate it from the second piece, for whom I can pull out the 12, but not the 3 minus 4x, which is going to have to stay. Because it's not this isn't multiplying, it's being subtracted. We can only pull out things that are multiplying. And the reason I can pull out the 12 is because you could see it as multiplying with 1 over all that. So that's why we can pull out the 12. Integral of 1 over 3 minus 4x dx. From here, I recognize, first of all, that I have a linear expression inside, and I have a linear expression for the denominator, whereas my formulas are for there just being an x down there, right? So I know I can use my formulas, but I know I need to use the chain rule as well. So let's do it. We're going to copy down the multiplier in front, and the integral of 1 over root x is 2 root x, but instead of an x, I have 3x minus 1, and because it's a line, I'll divide by the slope of the line. Let's do the next part. Minus 12. The integral of 1 over x is the natural log of absolute value of x. But instead of an x, I have this line here. So I need to divide by its slope. In the last step, I'll just simplify it down. This 9, and the 3 becomes a 3 over 1. So multiplying across, I get 6 over 5 root 3x minus 1. These two negatives cancel out, giving me a plus 12 over 4 is 3. 3 minus 4x. Ta-da! And that's it for this part 2.